Thank you very much for being here bright and early in this beautiful space. I was very happy to see that the theme of this conference was storytelling, because I think that as we come up with new ways of collecting information, gathering data, processing that data, visualizing it, sort of putting it back out in the world, displaying it, sometimes we risk focusing so much on the technique of how to do that we forget to tell stories. I think storytelling is a basic human activity. I think you may have noticed yesterday at the reception, if you were telling a story to someone you just met, that maybe you change the pace of it, maybe you add more explanatory detail than you would if you were talking to a friend, right, who's known you, who you have shared experiences with. So we can adjust our stories based on who our audience is. And so for me, for graphics, where we don't really have that luxury, right? A graphic needs to stand on its own more. So the graphic needs to sort of contain that explanatory material so that it can be applied to a range of different audiences, right? I can't be looking over the shoulder of every Times reader. I have to build that thought, or try to build that thought into the graphic. So for me, probably the most important thing about working with data and trying to tell stories is to have an audience, right? And I'm in a paper, obviously, but you may have different audiences. You may consider them viewers or listeners or users. But for me, so I try to think, like, who might that person be? So if I believe Times advertising, right, maybe it's someone like this, right, the subscriber, right, or someone like this, the visitor, sort of enjoying the 20 articles a month. But that's not very compelling. I'm not compelled to sort of speak to them, to try to communicate any understanding to them. Sometimes we talk about print readers or web viewers or people on a tablet, and that can be useful for development. But it puts the focus on the mechanism that they're getting the information, the mechanism they're getting the story, not the people who are receiving it. Sean Carter, who does a lot of our interactive graphics, really wonderful work, he likes to think about designing for Bart Simpson and for Lisa Simpson, right, where the Bart Simpsons of the world might need or might want sort of an initial view, right, so a quick sort of overview of what the data is showing. And then the Lisa Simpsons of the world might want to spend a little more time with it to interact or to sort of delve down and understand. And that can be a very useful way to think about, particularly interactives. For myself, I like to think about three sort of types of people. I do mostly science graphics. So I usually think about someone like a high school science student. And the image is blurry because it's not really the details that matter to me. It's more the sort of the idea of that person. So I think about a high school science student. I think about a busy commuter, right, who might still read the print edition, but could be easily distracted, could easily go to their phone or play a game. So how do I keep them sort of interested in a graphic? And then I think about someone like my grandmother, who was an artist. She was married to a chemist, and she always she loved seeing my graphics in the paper. But she really focused on the art of the thing, right? If it didn't sort of hold together as a cohesive visual whole, she kind of wouldn't hesitate to tell me sometimes. So what's the point of this exercise, right? My readers may be different than yours, but why would we bother imagining them? And the whole goal is really so you can design for somebody else, right? It's very easy to start researching something, understand something, right, get some data, and then you make a graphic that speaks to you, speaks to your understanding. So I try to be very careful to not do that, right, and try to design for these other people. And so these three, they give me a range of ages, they give me a range of experience levels, maybe a range of interest in science. So if I'm trying to explain something complicated, I can sort of try to dial it in and get away from my understanding of the material. And there are a lot of pitfalls when trying to explain sort of data-rich information, right? You can err on the side of oversimplifying, speaking down to your audience. On the other side, you can also have sort of too much detail. I run into this a lot with science, where you're sort of so excited about the data, you want to sort of cram it all down your readers' throats. So try to use that, my sort of fake audience to try to dial in somewhere in between. I also try to make sure that I'm really explaining the data and I'm not just decorating it, right? You can come up with a really nice form sometimes that speaks to you think is cool. but that may not be the best way to explain. So I try to iterate and sort of come up with something that really explains the data and is more on the sort of the left side of the scale. And then I think many people today will be talking about this, right? Where do you fall on that line between sort of a real narrative storytelling and then something that's more interactive, allowing the user to maybe find their own patterns or pointing them direction and sort of letting them go. And that's a very interesting process. I'm very interested in seeing what other people have to say about that today. And the key, I think, as I've said, is don't be your own audience, right? You already know the story. So if you're talking to yourself, you're missing a chance to communicate. You're missing a chance to tell a story. And in science, I see this quite a lot. This is the LHC particle collider outside of Geneva. Right? And so it's this multi-billion-dollar machines, 6,000 or more scientists spent decades sort of building and planning this thing. And they collect some mind-boggling amounts of data and try to process it. And a lot of that work is focused on trying to find the Higgs boson, right? Or trying to find does this particle exist? And so last July, there was a big sort of gathering. There was a lot of rumors flying around, like have they discovered, have they found evidence of this particle? Right? And so they all meet. Everyone's very excited. I was dialing in on a webcast. I think many people around the world were doing the same. Right? And then you get to the big sort of discovery moments, right? And the slide looks like this. Right? So, and it's not. There was a lot of criticism about the design of the slide. It's not so much the design. It's that it's speaking, right? Speaking to themselves, right? If you're in the audience, you know the backstory, right? I mean, you've done all this amazing work. You have this background of knowledge. So this really tells you something. But if you're like me. Right, or other people, you're just, where in this slide is the point? And so you really need, if you're not sort of already in that crowd, you need a translator. So that's what I try to do. I feel like a lot of the work that I do is maybe less design, more translation. And so I'm not going to try to explain the Higgs boson, but I'll try with something a little simpler. So what I try to do is I try to find that central idea, right? Often in a scientific paper, there'll be multiple ideas that are interesting. I try to find one and see, can I extract that out of here and maybe use that as a basis for a graphic? And then once I've done that, right, I can't just put that out as a fact. I've got to try to find evidence that supports that. So I'm trying to understand the material. Sometimes that can be difficult. Try to translate it for my hypothetical, those 3 readers I have. And then try to find an interesting way to display it. And then that's not quite enough. I need to make sure that I've then explained that material to the readers. So this is a typical paper that I might start with. This is kinematics of foraging dives and lunge feeding in fin whales, right? So from the very first word, I know this is not for my audience, kinematics, right? But the idea is interesting. Researchers went out, they put these sort of suction cups in the back of whales, they watched them, or they tracked them go through these sort of 7-8 minute, very deep, feeding dives. And when they get back, they make a slide that looks like this. And so this is maybe speaking to other scientists, and maybe speaking to other biologists, but it's not speaking to my audience. This is a little farther along in the paper. So you've got a big chunk of text that's sort of telling you what's going on in the graphic, but the two are very separate. So if I try to read this, I'm going back and forth, sort of left to right, trying to follow the logic here. So I didn't really see much I could do with these two. But then later on, there's this graphic, right? And this combines some speed information, some other like pitch and roll. But what it has is this, right? Something that's actually tangible. This is a depth chart, right? So it's showing, on the left, it's showing the whale sort of at the surface breathing, making this very long, deep dive, making these sort of bumps at, 250 meters down, and then coming back up. But of course, being scientists, they cut out the whole middle part of the chart, right? Because they're interested in the top and the bottom. In the middle, there's, not much data. So what I did was first thing I did was I contacted the researchers and got that data and plotted it, right? So from those charts, right now, this is something tangible that I can use as a basis to explain. So now I can show what this whale does, where it's going, but I haven't explained what those bumps are. And so, right, and I can link this to some of that other data that we saw in that previous chart, the speed, the fluking, which is the pattern of the tail going up and down. And you notice that the speed, so the whale's going very fast and then stopping, very fast, stopping, fast, stopping. It does this 5 or 6 times. And I think it was a separate paper where there was this chart, right? Which is quite beautiful, but is somewhat hard to understand, right? It's showing those top 5, it's showing what this whale is doing at each of these bumps. And it's accelerating, these are krill feeders, it's accelerating towards this school or pod of krill. It's opening up its mouth, and the mouth acts like a parachute, right? It engulfs this enormous volume of water, like a bus full of water. It comes to a dead stop, obviously, closes the mouth, sort of spits all the water out, eats the krill, and then moves on. Right? So these are very elegant drawings, but they're combined with a very scientific chart, right, where there are 4 different variables plotted here. So again, I'm looking, what can I pull out of this diagram to explain? And I think that is probably speed, right, the black line here. So if I take that chart out, break it down into these sort of small multiples, then I can I can match time with what the whale's mouth is doing and with their speed, right? So you can begin to sort of understand this. And then I compare that with the chart. So now I've got the sort of the micro scale, what's happening in detail at the bottom, and then I've got sort of the larger scale, what's happening here. And we try to do our own writing and our own research. So this is the bare framework of the chart, and then from there, sort of annotate it. And so this is the final piece. And my favorite detail was just putting the whale in at scale, so you could get a sense of how deep this actually is. So all this is trying to respect that reader, right? Respect my audience, to help them through the story. So in this case, this was a print piece. So I designed it, I assume most people will sort of go to the headline and read this way, start that micro scale. But I also tried to write it so that if someone started over here, they could still come into it sort of a back way. Right, so that's very important to me, to try to not assume that everyone's going to start in the same place. To try to sort of write it in such a way that it's compartmentalized, that you can pick up here, and then maybe you don't go the way the designer intends, but you can still find your way through the piece. This is a very similar design, but much more complicated material. In this case, this is trying to explain how ice moves across Greenland. And so this is kind of more on that sort of towards overwhelming detail. I try to make it as simple as possible, but in this case, it really, I kind of did design it to be read this way. But I still try to put a little something in the upper right-hand corner, so that if someone is really interested in this chart, that they can have some idea of what it is we're talking about without reading this, this long block of text. So this is the final piece there. And so this is just trying to combine visuals and charts and data in such a way that it sort of explains a concept. This is another piece, not my own work. This is Hannah Fairfield, who will be speaking later. This is really a static data set. It's looking at relative performance of girls and boys in science exams. And so although the data doesn't move, right, the data is not shifting around, you can see that it's what we usually call a stepper, right, where you can read a small bit of annotation and you can move through it. And as you move through it, different parts of that data are pulled out and highlighted. So it lets you begin to tell sort of a narrative, but with the same static data set, right? So you don't necessarily need a lot of motion to get this through. It can be as simple as sort of letting readers pace themselves through. And that is a nice thing about this sort of format, is that you can read a blurb, understand it, and then the reader decides to move on. You're not just kind of forcing them as you might in a video. And so the direction of sort of motion is this direction. For complicated pieces, I often think about using multiple scales. So I try to not keep everything, at one level. This is a piece, it's not my own piece, this is Kevin Quayle and Graham Roberts. So they're picking up off of news in the Olympics, right? Greg Rutherford wins the gold in long jump. And so rather than just sort of show this, like, we want to try to put that in context, right? How might we do this? So they're sort of giving you one jump, they're giving you this length, and then the whole rest of the piece is trying to explain, to put that into context. So it's backing up, it's looking at every Olympic medalist through time. And as they pan out, you realize that what they've done is they've taken these long jump, tracks, and turn it into a bar chart. And once you have that bar chart, you can start overlaying information. These are United States medalists, right? You can start looking at, okay, most people jump 25 feet or more. what does that mean? What is 25? I have a sense of it, but is there a way that we can explain that a little better? So they zoom in and give us an NBA court, right? They're drawing connections between two disparate sports. So looks like everybody jumps past from the free throw line, and then quickly they'll zoom over and say, well, what about the three-point line? There's only one, right? So it's going from a small scale, panning out to a large scale, coming back in for a data point. It continues on to show some other notable jumps that athletes that people might be familiar with. But I really like this piece because it is playing with scale and narration. It's starting small, coming out, coming back in. It's moving through time, and it's doing this somewhat seamlessly, right? There's no real change. The people aren't moving. It's just you're taking different views, different slices of this chart, this data. And then other things like showing wind speed. Right? So it's a very, very beautiful, very, very light touch, but showing a lot of data and a lot of context. These I've shown. And so this was the piece. I encourage people to look at it. They did 2 others, and all of them are quite nice. So that was narration. That was like linear, trying to talk someone through data in linear time. In print, right, we can't narrate, so we try to annotate. And I always try to draw a distinction between, I don't want to just label everything, right? I want to try to have meaningful annotation that explains what's going on. So back to my grandmother, she was an artist, she was married to a chemist. She used to say that when they would go to museums, she would look at the art and he would read the labels, right? And so that's what I don't want to do, right? I see, so here's a museum experience, right? There's art is over here and then the label is somewhere else, right? So you can choose to look at one or the other. Science papers are similar, right? Maybe this is 4 pieces of art here, and then there's a label on one side, and you're going back and forth, right? And there's a lot of redundancy here. There are labels, right? We're labeling parts of the, this is a flea, labeling parts of the flea's leg, but there's not a lot of annotation here. So this is from a paper, Biomechanics of Jumping in the Flea. So it turns out there's a long-running controversy about how fleas jump. Do they jump with do they push off with their feet, or do they push off with their equivalent of a knee? Right? And they're very small. It's very hard to tell. So so this paper, they tried to solve that problem. So they had these sort of, I think, beautiful images of this flea beginning to jump. And then they have these very nice sort of line drawing of what the leg is doing at each point. But again, there's not a lot of annotation here. It's sort of an odd format, like the sequence is going up and down. We're getting these time stamps. There are really only 2 pieces, I think, this first movement of hind legs and takeoff, that are really kind of saying what is happening at this moment. So this is a great idea. I really want to explain this. So the piece was more like this, right? Like putting it in a sequence, right? I'm basically taking the same idea the scientists were trying to use to convey this information, a line drawing of the leg, along with an illustration of the parts of the leg, but trying to combine that in a way and annotate it so that you can follow along as this flea lifts off the ground, right? In a way that you couldn't in the original paper. So, right, these little italic texts are sort of annotating each step. So this is the full piece. Right, and so we're trying to show change, right? I mean, I think it's hard to have a narrative, it's hard to have a story without showing some type of change. So I'll show a few graphics without explaining them too much. But this is motion, right? Motion lends itself very well to change, whether it's, in this case, a flea or a cell. So I use this sort of sequencing very frequently by showing the large scale and then the small scale detail of what's happening each step. It could be the movement of a spacecraft, in this case around Saturn, right? Giving you some sense of just the complexity of designing this sort of movement. Could be something much smaller. It could be this is not motion, but this is kind of a change in form. These are different types of RNA and how they're manipulated, how they change inside the cell. Could be ways of speed cubing. How do you sort of memorize these patterns and come up with almost sort of on autopilot solutions? It could be like a standard chart, right? This is showing meat consumption over the roughly the past 100 years. But instead of just putting the chart up, showing that data, I tried to really put a layer behind it. Where are the world wars, right? Where was the Great Depression? How might that affect change in meat? and then try to annotate it, right? When did the first McDonald's open? When did the 1000th open? Try to load ad campaigns that people my age might identify with, right? Where's the beef and the other white meat? So it's a simple chart, but we're just trying to add to it, to try to let someone spend some time with it and maybe get more out of it than they might if it was just, just the lines. Or something like this. This is trying to show at the bottom 600 years of sunspot activity. And then this is an image of the sun during a very strange lull we had several years ago. All right. And it could also be a timeline. Right? We do a lot of timelines in the paper, but trying to find different forms for them that are not just linear left to right. So this was showing trying to show all 135 shuttle missions. So each column is its own shuttle, and each sort of bar is its own mission. Right? And then trying to annotate it for ones that people might remember and color code it based on what type of mission it was. And along the way, right, we always need to be careful to reduce complexity. Right? That's part of the not getting into overwhelming detail. And by doing that, you can help sort of reduce opportunities for confusion. This was a graphic. It turned out to be a video. This is also not my work, but it was looking at pitches thrown by Mariano Rivera, and I think it were 1,300 pitches in the 2009 season, if I have that right. But it didn't start as a video. I think Sean Carter was working on it, right? And it started as a set of data. And so he read this data in, and he started manipulating it, playing with it, seeing what was there. Right? And so from this initial sketch that was for sort of his internal use, I think one of the earliest sketches was something like this, where you have the data, so let's build an interface around it that lets you filter it, that lets you sort of see additional information about different types of pitches. Right? So could this have been made to work? Yes, it definitely could have. But it is not, in some ways it's adding interface. It's not adding data, but it's adding sort of complexity around the data. So they decided, rather than go this sort of more interactive route, to go more into a narrative. And I won't show the video, but I highly recommend it. So they start with just simple explaining single strikes being thrown. And then they move on to an image of all pitches, right, a moment after they left his hand from this perspective and from the batter's perspective. So right, you have 1,300 pitches coming at you, and then here's where they end up. And it goes on. It sort of turns these into heat maps, and it shows how different types, how he's such a hard pitcher to hit. So could this have been made more interactive? Yes, you could. You could have set it up so that you roll over any ball and you get more information about when it was thrown. But does that add anything here? Not really, right? It adds complexity, but it may not add understanding. Okay? So this is a very, very nice piece. And again, I thought this piece had found a very nice balance on these scales, right? It keeps it simple without overwhelming. It is explaining, and yet it still looks very elegant. It introduces that sort of the real world. Here's an actual baseball, not a point coming at you, and it's very very nice narrative piece. Along the way, we want to try to reduce tedium. Right? We're trying to respect the reader at all these points. So how can we reduce tedium? How can we get them interacting with the data points themselves, right, and not the interface? This is from 2010. This was just every year the Times does a year in pictures. And so I think there are 97 photographs here. But the only way you could move through them, I think, was to click the next button, right? So it's sort of hit a pellet, hit the button, get a pellet, hit the button, do that. So I wanted to see all 97 of these, but I think I made it through, I don't know, maybe 10, and then I gave up. And then later years, the Times fixed that. So now you can at least do like a mouse key, like an arrow key, back and forth. So in graphics, we try that same thing. We try to find how do you find like sort of tedious activities and strip them out of a graphic. This is not my work. This is Sean Carter and Mike Bostock. Many of you may have seen this. This is about electoral votes in the last election. And the beautiful thing about this is that the whole area of these art is all you need to do is roll over it. And as you roll over, you see these different outcomes. You see these sort of this decision tree. It flips back and forth, right? And you don't have to click every circle, right? It's 512 passes to the White House, but it's not 512 clicks, right? It's just everywhere I move, this is fluently moving following my interaction. So it's a zero-click interface. And the way they did this was quite elegant. They put these Voronoi tiles over it so that no matter where you were in this field, you would highlight the closest circle. So for these very small circles, you don't have to hunt as much as you're not trying to hit like a little 4-pixel target. And then, of course, you can click it, right? You can narrow as you click on states, as you send them to Democrat or Republican, right? The image itself refreshes. So this is a beautifully done piece. You also need to be careful to remember that visualization, right, does not always equal explanation, right? Sometimes you visualize the data on the way to explaining it, but often that visualization does not by itself sort of work out as an explanation. It doesn't itself tell a story. And so sometimes if you're really sort of focused on how you're visualizing it, you can get sort of obsessed with the technology and kind of forget to tell that story. So this was the journal news. This was, I think, late last year. This is quite controversial, where they got data on gun permit holders in 2 New York counties, and just put that out there in this format. The data has since been pulled down. It's just flat images like this. But so leaving aside the issue of whether this should have been published or not, just looking at the form of this, right? It's saying, I don't know the process, but what it looks like as a viewer is that you have this data, you put this data on the web, or you run it through a tool, and then you just put the output of that tool, you just sort of put that up. So in this case, there is no overview, right? It's showing me a pattern here, but it's unclear what that pattern is, right? It looks like there are more gun permits as you get closer to New York, but is that because there are more guns there, or is that just more people living there, right? There's no additional information here that helped me understand this piece. It's just here's an overview of the data, the pattern, and then it really encourages you to go click on these things and see individual people. So we try not to do that, right? If I try to do the same thing for science, if I said, okay, here are earthquakes, right? Click on any dot, and I'll tell you what earthquake that was. Right? This is missing a huge opportunity for explanation, right? There are clearly patterns here. Those could clearly be explained. So just say, like, if you're using tools, be careful that output, you're not letting the tool sort of decide what the visualization is, that you're using the tool, and that you're taking that output, and you're making sure that it is telling the story that you want to tell. Right? And so we try to reveal these patterns, right? And then we try to explain them as best we can. So what are some other ways that you might, these next examples are not my work, but what are some other ways that we might have done this, right? This is also point data. In this case, these are homicides over almost a decade in New York. This piece is about 3 years old. So the points are there, right? And you can roll over them for detail. But what it does is it builds this sort of somewhat simple interface around it, where it lets you filter, it lets you get data on race, it lets you get data on the gender of the perpetrator and the victim. So it is point data, but it's trying to, in the same way that Hannah's piece was doing, it's trying to pull out, highlight different sets of that data so that you can find your own patterns. There's not a lot of narrativity here, there's not a lot of narrative, but it's encouraging you to find your own patterns and ask questions in that way. You can take data and you can aggregate it, right? This is also sort of on that gun theme. These are 50,000 guns recovered over about 11 years in Chicago. And where do those guns come from, right? So these are using circles for each county. So it's a very elegant map, right? There are a lot of guns came from Chicago area. But then you start to see patterns, like what's happening here in Mississippi. So rather than just sort of put this out there, right, they used the design of it to then go on and try to answer these questions or try to hint at what some of the answers might be. And you can also sort of use, instead of using the points themselves, you can abstract it in many different ways. This is just one sort of heat maps, patterns. And so here it's a pattern. This is also showing killings in Chicago. And then you can underlay different types of data. So you sort of encourage people to see patterns and then try to come up with meaningful annotation along the way that sort of makes this a story and not just a visualization of killings in Chicago. And so all of this is part of respecting the data. And so if you have a data set, right, try to find out what is unique about it. Like what in here do I really want to explain? There's a piece on Guantanamo from a couple years ago. This was not my work, but the Times has been gathering data on detainees held at Guantanamo for more than a decade. And so this piece, was you could play it or you could scrub through it. It shows detainees arriving. This is broken down by major countries. And then it shows them as detainees are gradually transferred to other countries. So each detainee is represented by a square, right? So you could roll over for more information in that way. Right? So it's a very, very elegant, you can see sort of shifts in time, and it plays very nicely. I'm only showing sort of clips here. And so I was asked to do a print, sort of the last minute I was asked to do a print version of this graphic. And so, I'd used the data before, to do very simple charts, like just showing, kind of taking the detainees and aggregating everything together, showing a simple chart like this. Other people in the department have, Hannah did a piece that, used squares and tried to show a similar effect in print. People have used, cubes, tried to show, just give some sense of these patterns of where detainees might be going. And then people, not at the times, like a lot of people have taken sort of these numbers and tried to come up with some visualization of what they show. But does this really show what's unique about the data? I mean, I kind of wanted to avoid this sort of iconic approach. And I definitely wanted to avoid this kind of approach, right, where it's just, here are some numbers, right? This chart, it says Guantanamo, but it could be really almost anything, right? I don't drink coffee, but I drink tea. Right? So if I change the title, right, I drank 779 cups last year, 600 of them were hot, right? 8 of them were herbal. Right? I could tell you a story, but there's nothing, right? It's the same chart. There's nothing here that is saying what do I think is interesting about that data set? What is, what I'm trying to explain about that data set? So I definitely did not want to do things like this. And so I got the data, I got a sort of a simplified export of this large database. And so what do you do with this, right? So, we try to edit. I tried to, how can I throw as much of this away, but still tell some sort of story? Right? There's a reason that our titles are graphics editors, right? Because that is what we should be doing. I think if you find yourself sort of spending more time editing your graphic than actually creating it, you're probably doing something right. I really enjoy that process of honing the graphic, taking everything I can out of it, and really trying to clarify, sort of tell that sort of gem of a story, and then sort of try to send that out in the world. So I thought, well, why don't we just strip out everything except the dates, the arrival and departure dates. This is sorting everything by date of transfer. And so this is, I don't know if you can see it, but this is kind of an ugly shape. So I quickly threw this one away. Maybe sorting by date of arrival and grouping by country. Maybe that starts to get some sense of who is here and what has happened over time, over this many years. And this looked more promising. So it was a course of about a day, went from the data to building this. I did this just in Python, but honestly, this could have been done in Excel. Right? It's very basic. It's a start date, end date, and it's sorted in a couple different ways. And then, so once I have this form, I try to hone it, try to explain it, try to annotate it, and just showing the progression sort of over the course of that day, a fairly quick process. And then this is the final piece. So even here, without reading the annotation, you can begin to see patterns of countries where some people are already gone, countries where there's still many detainees remaining, and then highlighting a few of the ones that people might be familiar with. And so this ran as 2 columns on a full page. So I've been at the Times about almost 8 years now, and this photo's about maybe 3 years old. I think we have a few new faces. And I think I might still be the only person here that has like a real design background. Most people come from, cartography or journalism or geography. I mean, it's a wide range, a much wider range than I was expecting when I arrived at the Times. But I think that what these people all sort of have in common. Here we are in our more native environment. This is cleaned up, right? This is our day-to-day morning meeting. But they're all very good at applying common sense, right? And they apply it kind of ruthlessly and vigorously. There are a lot of things you can do with data, right? There are a lot of ways you can get sidetracked into sort of focusing on the data and not focusing on your reader. And I've learned an enormous amount being there just by watching as people sort of try something, throw it away, try something else, throw it away, really trying to find that, not what's the easiest thing I can do with the data, what's not the coolest looking thing I can do with the data, but what can I do with this data that tells a story, right? That really tries to explain why this is unique and why this is interesting. It's easy to get overwhelmed when you're working with data, or there's so much you can do, but I would just say that, of anything, if you're going to do anything with data, please try to make those connections, right? And try to take some understanding of your own. Try to put it in a way simply that you can send it out in the world, and hopefully someone else, some reader, listener, viewer, will pick that up and will share that understanding with you. So thanks very much.